Thought this would be a good way of explaining what's going on here. I took this paper. The paper is called Stellar Metamorphosis versus Establishment Dogma, the Evolution of Stars. And to keep things simple, I put two diagrams on here, and an explanation for the public are provided which outline the main differences between Establishment Dogma, and yes, it is a dogma, and stellar metamorphosis and their predictions of star evolution. Now I took this from Wikipedia. You'll see here you have the life cycle of the sun, where let's go ahead and point a few problems out with this. They have the sun as being born in zero time, meaning there's no actual process to birth stars. You think that if something as huge as the sun would have some type of process, but no, they don't have any process. It just appears because of gravity, which is really strange if you think about it. And then it just stays the same size for billions and billions and billions of years. And then it expands into a red giant, which then explodes. That's the really strange part. And then becomes extremely dense. So to think that they actually believe this is how stars evolve is a bit disappointing for me because of so many issues with it. One issue that I can see here is that they don't have the sun as losing any mass, even though it's radiating and there's a solar wind and coronal mass ejection coming out of it for 8 billion years. I mean, look at that time scale right there. I mean, look how wide of a time scale that is. I mean, it doesn't lose any considerable mass at all. That's I don't think that's plausible. I don't think this whole thing is I don't think this thing is plausible. And a few things that I'd noticed I wanted to point out to the reader is that there's no red dwarfs in here. Where are the red dwarfs at? They don't exist in the evolutionary models of the sun. Where are the brown dwarfs at? They're not in here either. Where are they? No black dwarfs, no blue giants, no gray dwarfs, and what I think is the completely false position of planetary nebula as being right after red stars. So up here they have a planetary nebula coming right after a red star, which is really strange. If anything, the planetary nebula should be way over here, and that's what I'll show you really quickly. And obviously, you know, they have the sun being born absent a gravitating body. What I really meant to say was absent mechanism. If you don't have a gravitating body, there is no mechanism there. They just have the sun just appearing out of the aether, which is really, really strange. How do you get gravitational field if there's no gravitating body to begin with? Clearly, the process of stellar birth is something else other than gravity. It has something to do with very large electromagnetic processes that can pinch material in very large amounts, but more on that later. On the second page here, I went ahead and did a preliminary outline of what I think is going on. This is what I think is the actual stellar evolution timeline, okay? What happens is you have a newborn star, and those are the nebulas, the planetary nebulas that are really, you know, violent looking. They have these weird rings around them, and that's evidence for magnetic fields being in there. It's evidence for a lot of activity. So look up planetary nebula and you'll see them doing really strange things, and then you'll see a little dot in the center. And I think that dot in the center is the very brand new star. And as it's being born, it then sheds away what you would call its I don't know. I guess I was trying to think of a term they use for birth. Embryonic sac. I don't want to say that, but anyways, it sheds all of its material away, and then boom, the umbilical cord, if you will, is released, and the star is a white dwarf. And that's a newborn star. They're about 1 million years old. And what happens is the star expands as it's trying to radiate the heat away. And it expands even more, 5 to 10 million years old, and expands even more. Eventually it becomes a blue giant. So a blue giant would be then result of first planetary nebula where the star is born, and expanding from a white dwarf all the way up to the size it is here. And then it reaches a point to where it gets the biggest it can get, and that's about 10 to 20 million years into the star's lifespan. And then you go over here to the smaller blue stars. They're still very, very hot. And then you get the white spectrum stars and then the yellow spectrum stars, which is the sun, and the sun is around 60 to 100 million years old. And then you have your orange dwarfs, and then you have your red dwarfs, your auburn dwarfs, that's what I call them. I was trying to think of something in between brown and red, so auburn. Then you have Jupiter and Saturn. You have your gray dwarfs, and then you have your Neptune and Uranus worlds, and then you have ocean planets in between Neptune and Uranus and Earth, which are supposed to be like around this area right here. And then you keep on cooling, and dying, and eventually the star dies completely, and it becomes something like Mercury or Venus. And they just populate the galaxy all over the place, and they just smash into whatever it is that's in their way. So basically what we have here is that you have the stars kind of ending their shining life, if you will, right there. And then the really small ones, actually red dwarfs should be on there too, so the cutoff point would be like toward that area, and then this would be like more infrared, and as it moves down to where you cannot even see them anymore because they're just too old, they're too dim, and they're not called stars anymore by the establishment, which is really strange. But anyways, I try to do this because then it can fit Earth into something more or less like 3 to 10 billion years old, and Venus and Mercury would be older than 10 billion. Now I know that would probably fit inside of a Big Bang kind of paradigm, but I actually reject Big Bang because chances are more likely that Mercury and Venus are many tens of billions of years old, maybe even 70 billion plus years old. But that's to be determined by the thickness of the iron core that's inside its center. But anyways, there you have it. My justification for the ages of these objects. And if you notice here, I don't actually date the stars based off their metallicity. I actually age the stars based off of their physical appearance, what their actual physical characteristics are, not how much iron they have, which is ridiculous. Not only that, but I think the metallicity argument really doesn't, it's not comprehensive enough. Plus, you can't be scientific with it because you'll find stars that have lots of metals that are like the sun size, and stars that don't have a lot of metals in the spectrums, and that could be caused by dust in front of the cloud or dust in front of the object, which is obscuring the object. I mean, you have to always keep in mind that outer space isn't going to be some perfectly viewable construct where you can see things without any interference at all. But basically that's it. So we have Jupiter and Saturn being quite younger than Neptune and Uranus, and Earth, Mercury being way, way, way older. So what this does is it kind of does away with the nebula hypothesis, because you can't actually age stars that way. It's impossible to think that everything is just a big disk and then it becomes all these different objects. That's strange. To me, it makes more sense to have the star start out as something that's very turbulent and violent and electromagnetically powered, and then it retains its spherical shape as it moves along basic evolutionary paths. There's no disk required. If anything, all a disk is say one of these little objects over here smashes into one of these, or gets torn up or smashes into each other, and then it could create large disks around the objects, and we call those rings. But basically, yeah, that's it. Today is February 10th, 2016. Hopefully this helps people out a little bit. I'll link this paper to the bottom of the page.